Hello everyone. My name is Jerry Lowe. I'm the Head of Technology for Advertising and Marketing Solutions at AWS. Welcome to the AdTech track at reInvent. A unified view of your customer can enable you to identify or predict exactly what the interest level of your customer is in buying your product, and then act on it. This goal is exactly what Carlos and his team achieved at Cox Automotive. In the following session, you will learn why they picked Neptune and the lessons learned during this journey. Your feedback is very important to us, and your participation in the customer survey at the end of this presentation is very much appreciated. A big thank you, and welcome to Carlos.
Thank you, Jerry, for that wonderful introduction. Today I'm going to talk to you about how you can reach your in-market customers before they reach out to you so that you don't miss out on a potential sale. At Cox Automotive, we've built something called an identity graph, and that's serving as a foundational capability that enables use cases like the ones I just mentioned, as well as other advertising and marketing capabilities. We're using these today to help our dealerships, which are our clients, car dealerships, as well as automotive OEMs, reach their customers today. So let's dive into the agenda. First, I'm going to talk a little bit about Cox Automotive so you guys have the business context of everything that I'll be talking about. Next, we're going to talk about an ideal consumer journey. What I mean by that is, what does the car shopping journey look like for the consumer? And specifically, what does it mean from the context of advertising and marketing? From there, we're going to talk about some of the challenges of realizing that ideal vision. Specifically, a couple key takeaways for those of you attending. One of the big challenges is tracking consumer identity across multiple data sets. And the challenge there is consumers often have many different identifiers. And because of those many different identifiers, it's hard to know that they're all the same person. So we're going to talk about how to bridge that gap. We're also going to talk about something called the post-cookie world. And specifically what we mean there is using third-party cookies to track consumers across multiple different websites. We found that that doesn't work very well anymore, and we're going to talk about what we've seen in our own logging and some of the approaches we've used to mitigate that. From there, we'll talk about our journey to building an identity graph. What did we build out? What technologies did we use? Specifically, we chose Amazon Neptune. Why did we choose it? We'll present the solution architecture of our whole solution that I mentioned before, and we'll wrap up with some lessons learned, both from creating an identity graph and using Amazon Neptune. And after that, we'll have one final bit, which is our internal results that we're seeing, as well as some customer quotes from our customers and how valuable this is to them. So let's talk about Cox Automotive. Our mission statement's on the slide. It's a very lofty mission statement, transforming the way the world buys, sells, owns, and uses cars. Cox Automotive is a very large company. We've come together through conglomeration. You can see that there's many brands listed on the slide, of which there are many more, but here's just a few key ones you may recognize. For the purposes of this talk, I'm going to hone in on a few of those particular businesses because they're important to what I'm talking about. So just to give you a brief overview, the first one is Autotrader.com. Autotrader.com is an online marketplace. Think of it as classified listings for automobiles. And it's primarily used by dealers to list their inventory and consumers to find new inventory to buy. Next, we have Dealer.com. Dealer.com helps dealers host their websites. And they also help them advertise as well, which is an important piece. Next, we have Kelley Blue Book. Kelley Blue Book is a consumer website that helps consumers do research when they're car shopping, as well as tell them what their current car is worth. Finally, we have VinSolutions. VinSolutions is a CRM solution for car dealerships. So hopefully you can keep all of those in the back of your brain as we go through the ideal consumer journey. All right, so let's think about what happens when you go car shopping. So let's pretend I'm car shopping. And if you're like me when you go car shopping, you start doing some research online. You might go to sites like Consumer Reports, you might search the OEM's websites, you may end up on Kelley Blue Book and watch some editorial content. You may price what your current car is worth. There's all of these digital interactions that are happening. And as you get closer to purchase, you may end up on autotrader.com to see who has the vehicles that you want to buy nearby. And from there, you may even end up on individual dealers' websites, learning about where the dealer is located and information about those businesses. Now, let's assume for the purpose of this talk that in the past, I'd bought a Ford vehicle. And as I'm car shopping online, and as I start to get pretty serious about looking at a new vehicle, maybe it's even a competing vehicle like a Honda, that's the perfect time for that dealership to hit me with a marketing message. And they could send a message like this one. This is an email that we can send out today from our automated marketing platform. And this email is very personalized to me. So the dealer is offering a specific piece of inventory on their lot that is tailored to my interest online. It's not the Honda, but it's a comparable Ford vehicle. The dealer also did business with me in the past, and in this case knows my financing information. So in this case, they're offering me a specific financing offer as well. So what we can see here is we're able to bridge both that online data about a prior purchase, financing information, as well as online data and those interactions that I'm having, and the dealer is able to hit me with a very relevant message at the right time. Let's look at a second example that we're enabling. This screen that I'm showing you is one of the screens that's present in the VinSolutions CRM. And this screen would be looked at by a salesperson at the car dealership, either when you're there in person or when they're calling you to follow up on a lead. The salesperson's able to see where you are in the car shopping journey, that's the buying signal. And they're also able to see what I'm most interested in online. So you can see the makes and models that I'm most interested in, body style, price range, mileage. It's a wealth of information given to that salesperson, and that really helps them tailor their conversation with you. And it really prevents something that can be pretty painful if you've ever gone shopping for something and worked with a salesperson and had them steer you towards something that you didn't really want. And so it removes the friction, it keeps the salesperson from doing that, and it also helps you as the consumer get a better experience. So those are a couple examples of the full, complete picture that we want to deliver. So the team I work on at Cox Automotive is the Consumer Insights team, and this is our product goal. This is what we're trying to accomplish. We want to have a connected consumer journey, and really what that means is we're using all of the data about that consumer from all of the various different sources we might get it from. And that includes all of the different Cox Automotive businesses, and that also includes external providers. Some of those may be LiveRamp, Adobe, Axiom, or maybe even other data brokers. And it may even include large OEMs. We want to use all of that data about a consumer, tie it together, and then next what we want to use is machine learning so that we create reliable predictive insights. And really what that means is we can prove that those insights are good with hard data. And you can see on the slide, we already showed some of the insights, but these are the types of pieces of information that we want to provide for advertising and marketing use cases. You can also see that the identity graph is how we're going to look up this information for a given consumer. And it's going to allow us to look it up based on all the various different consumer identifiers that are out there. I talked about a couple specific use cases earlier. Here's a more complete list of the use cases that we have in production today. And you can see how we're thinking about them both from the consumer side, where we've got things like personalization and vehicle recommendations, to the dealer side, where we're helping tailor the experience for the consumer and hitting them with marketing messages at the right time. So the real takeaway here is that this identity graph technology is very foundational, and you can see that it's powering a wealth of different use cases at our business today. So next I want to talk about what's difficult about powering those experiences that I just talked about. What's difficult about creating that vision that we showed? So there's three things that really get in the way of delivering that vision. The first is that consumer identity is not shared across data sets. And what that means is it's hard to know if a given consumer is the same one in another data set. We need some way to translate, and that's what an identity graph is providing us with. It's also getting much harder to track consumers online. Consumer privacy, digital privacy, continues to be a hot topic. And due to that political pressure, we're seeing technology vendors make it increasingly more difficult to track consumers online. So we need to come up with ways to mitigate that. Finally, there's a lot of data to work with. And while Cox Automotive might not have the most data that you can imagine, say from a very large tech giant, we do have a very large amount of data in the automotive space, and we need a solution that will scale to that size. So let's dive into these challenges in more detail. Starting with consumer identity not being shared. So if you think about myself, Carlos Rendon, and how I look in our Cox Automotive data, you can see that I've got a lot of different identifiers. I may have multiple different cookies in our web logs. If I submit a lead, I'll have an email address. And if you're like me, you probably have more than one email address. You probably have several. In the CRM, in those data entries, I may show up as a CRM identifier. And also in our web logs, you may also see me as an IP address. And again, with IP address, there's both IP version 4 addresses and IP version 6 addresses. So the big takeaway here, as I've talked about a few times before, the consumer identity is not shared, and you need a solution that allows you to tie all these identifiers together to know that these, I guess there's 7 identifiers, are all the same. When it comes to digital privacy, and originally I talked about the post-cookie world, when you look at third-party cookies as a solution to tracking consumers across multiple websites, what we're seeing in our data is that it doesn't work very well anymore. On the screen, I've got the match rates. So this is the percent of consumers that we're able to track with third-party cookies over the weeks of the year 2019. You can see that there's been a steady decline over that whole year. And you can see that along the way, technology vendors such as Google and Mozilla have added more technical blocks to enabling that feature from actually working. If you look at the overall rate, the number of consumers we're able to hit, you can see that the majority of consumers are no longer trackable with third-party cookies. So the key takeaway here is you need a different solution than third-party cookies because you're missing out on more than half of consumers today if you use that as a solution. Let's look a little bit at the size and scale of Cox Automotive and the data we're working with. Every year we're working with 39 billion online interactions in our tagging software. You can also see the number of sales and online leads. The reason I'm sharing this with you is so you can get an idea for the scale that we're operating at and compare it to your own. All right, now we're going to talk about our journey to building an identity graph. What is it exactly? How do you store the data? How do you support it with technology? What does all of that look like? So let's dive in. On the screen, I've got a graphical representation of the identity graph that we've built at Cox Automotive. You can see that there's 3 layers on it currently, representing 3 different types of identifiers. On the top of the screen, we've got CRM identifiers. These would be identifiers in the VinSolutions software system. In the middle of the screen, we've got cookies, and you note that a single consumer may have many different cookies depending if they're using their mobile phone, if they're on their laptop, if they're on Kelley Blue Book, and maybe a different cookie on various different dealer.com websites. And it's pretty common for us to see that one consumer will have very many cookies. At the bottom of the screen, we've got the IP address. And we're using that today to help us tie together multiple cookies and identify them as one consumer. So overall, what you're seeing is we've got a graph structure with the vertices being the identifiers, and we're using the edges to express the relationships between those identifiers. Now your next question might be, this is great. If I had this, this would be very helpful, but how do I create those connections? So there's a couple ways we're creating those connections. One way is with deterministic relationships, and I'll walk you through one way that can happen. So say that I submit a lead online as a consumer, and then that flows to the CRM system. Well, when I'm online, I will have my cookie identifier, and when it flows to the CRM, now I can match the CRM identifier to the cookie identifier, and we've created that connection. There's a lot of different ways, if you get creative, to get your consumers to help you create those matches. In addition to that, you can also use probabilistic matching and data science. Our data science team at Cox Automotive has created something called householding. And with the householding, they're tying together a large collection of related cookies that they believe belong all to one consumer. Today we're using the IP address to be that primary identifier that we're tying them to. And I don't want your takeaway to be just group by IP address, because that's not really the full solution. If you think about it, my mobile phone moves around and it gets a lot of different IP addresses. And if you think about a lot of common occurrences, like me being at a coffee shop, when I'm on a cell phone tower, or when I'm at my office, or even a car dealership, you don't want to group all of those cookies at the car dealership together as one consumer, nor do you want to do it for the coffee shop. So there's a lot more that goes into it than I'm talking about today. But keep in mind that you can do this with the data science team. So the next big question for our team was, we've got this data, we have it connected. How are we going to store this, and how are we going to have it readily available for our use cases? Our engineering team did a few proof of concepts with different database solutions to see what was going to work best for us. Our requirements were that it would store all of our data, which is about 500 million records. And we wanted to be able to look up an individual consumer's identity very quickly in the realm of 10 milliseconds. When we looked at graph databases, we found that the data model was very easy to express and very natural, and easy to extend as we added more identifiers, which we plan to do in the future. We also found that the out-of-the-box query performance was quite good. So for example, we compared with relational databases, and the engineering team, it took them a couple passes to both get the schema correct for extensibility, and at the same time, get the performance that we wanted. It wasn't easy to get it right out of the box. At Cox Automotive, we're big Amazon customers, and we prefer when our database solutions are managed for us so that we don't worry about the non-differentiated heavy lifting. We also did some thought experiments and found that an in-memory database was a bit more expensive than what we wanted to pay for. When we looked at key value stores, we found that keeping them fast and flexible at the same time was going to be hard for us to do. And as I mentioned before, relational, it was a bit of a challenge for our team. So that's how we ended up using Amazon Neptune. We found that it met all of our requirements and worked great out of the box. Now, if your team is like my team, we had no experience with graph databases when we started evaluating. So I do want to share a quick Gremlin query on the screen, and Gremlin is a query language for graph databases. There's several different ones supported by Neptune. Gremlin is the one we're using, and I just want to show the query to you so you can get a feeling for how intuitive it is. If you select, say, start with the given cookie for a consumer, say the rightmost cookie on the screen, that visitor ID, that's what the first line of the query is doing. From there, the next two lines go out to the IP address and then go back out to all of the cookies that you see on the screen. And then finally, the last two lines are bringing in all the CRM IDs so that we have the full picture of all of the consumer identities. If you're familiar with relational databases and SQL, Think about how you would structure this data and think about what the query would look like when you run it and compare it to what you're seeing on the screen. Here's the solution architecture we built out. And I'm sharing this so you can use it as a bit of a recipe for yourself and get a feeling of what we actually built out. I'm going to walk through it very briefly from left to right, just so you know what all the pieces are. Starting on the upper far left, that's our consumer browsing data. So think of that as our web logs. And from the web logs, we then run the householding process I talked about. So the householding process is Spark running on EMR. That then creates our householding data set. And that's the data set that we want to load into Neptune. That has our linking from IP address to many different cookies. Because of the size and scale of data we're working with, we're using Neptune's bulk load API, and it expects the data in a certain format. So we have a second Spark on EMR job that runs and creates the data in the format required. On the bottom of the screen, you'll see the lead mapping data. That's where I talked about the deterministic matches between leads and the CRM system. We also load those with the bulk loading in Neptune using the same process that we talked about for the householding. In the blue, we have 3 boxes. Those are our 3 Amazon Neptune servers in a cluster. You'll see that we have a writer node that we run all of the writes to, and you can see there's 2 read replicas that are conveniently automatically placed in multiple availability zones. In front of that, Neptune automatically handles load balancing to all of the read replicas. And finally, on the far right, we have a lightweight API we built on Elastic Beanstalk. And the purpose of this API is to abstract a little bit of using Amazon Neptune and also to allow us to enforce business rules. So think about things like access and who's allowed to use which consumer identifiers. If you build your own identity graph, think about the type of consumer data you're putting into it. You may end up with a lot of PII, and that data usage may be restricted. So think about how you're going to enforce that. Here's some of the statistics from our use of Neptune, so you can get an idea of what amount of Neptune you'd need to purchase to reach the scale that we're at. You can see that we're using 3 instances, as I talked about before, and that we're producing about 2,000 queries per second. And the reason we're producing that many queries per second is because of our marketing and advertising use cases, where we want to hit the consumer with the right message at the right time, which requires us to constantly reprocess what we know about consumers and rerun it through our machine learning algorithms. If you want to understand the 2 graphs on the screen from CloudWatch, the orange line is from our writer node, and the blue and green lines are our 2 read replicas. You can see that we're not making full use of our current Neptune hardware, but we added room for growth as we expect to add more identifiers quite soon. One of the challenges we ran into with all of the solutions that we ran proof of concepts on was loading 500 million vertices in a reasonable amount of time. A couple things that we did to speed that up. One is performing incremental data loads. So let's not load the whole data set every day with the latest data. Let's perform a diff and only upload the incremental changes. And we're also making use of bulk load APIs, such as the one provided by Amazon Neptune, that allows us to load the data in the fastest way possible. So some of the lessons learned when we were using Amazon's Neptune. The first one, again, as I said, our team was not familiar with graph databases, was not familiar with Amazon Neptune. None of us had used it before. So we worked with Amazon to put on a training with our team to get us up to speed. We found this very helpful to make sure that we were modeling our data correctly and setting up our infrastructure in the optimal way. In addition to that, or if putting on a team training isn't an option for you, make sure you read their best practices. And I've included a short link on the screen. And those best practices really walk you through all the things you want to make sure you're doing so that you get great performance and everything works as it should. One other thing that's really nice about Amazon Neptune is if you're doing a large data load, you can scale the cluster up by changing to a much larger instance size on the writer node. And when you do that, you can load data much more quickly than you would otherwise. When you're done with your data load, you can turn it back down to the lower instance size, and that allows you to save both time and cost without having the larger instance size running all the time. And that's a pretty seamless transition to do that. From the perspective of an identity graph, we had actually quite a few learnings since we've been doing this. The first one to really think about is it should be real time. And you might ask yourself, well, why does it need to be real time? What difference does it make if I know that a new identifier, a new cookie, or a new CRM entry is tied to all the rest of the consumer data? Why do I need to know that at the moment? Well, the reason you need to know in the moment is if I show up and I start car shopping online on, let's say, a dealer.com website, and I start getting serious, you want to hit me with that marketing message at the right time. But if you're not able to tie that most recent activity to all the other information about that consumer, you're not getting the full value of your identity graph. So that's really why you need to make it real time, or as real time as you can make it. The other big learning that we've had is that the privacy landscape and the technology landscape is changing all the time. And because of that, I really encourage you, if you're looking to build your own identity graph or working with a vendor, make sure you have good monitoring on your key metrics. Match rates, how many of a given identifier you're seeing at a time. A couple things that we've run into, we ran a change where we switched to IPv6. And because so much of our traffic is on IPv6 today, it started messing up some of our metrics. As I've also alluded to before, as we've seen third-party cookies stop to work as well, we've also seen that change what we're seeing on our end. So make sure you have solid monitoring and alerting set up for that. Finally, as I mentioned before, with an identity graph, you're storing a bunch of consumer information, and you may end up with information that's either regulated or that you don't want to share to everybody. So make sure that you're thinking about the permissible use of the data, both from your own business's perspective and from the legal perspective. So let's talk about some of the value that we've seen from our identity graph at Cox Automotive. Internally, what we've seen, and this is mostly coming from our householding process, is that we're seeing twice the number of online interactions per consumer, which means that we have much more data to work with. And with most machine learning algorithms, having more data gives you much better results. We're also finding that we're able to use this identity graph technology for several different use cases. So once again, it's a very foundational technology, and you'll find lots of ways to use it. I'd like to share a few customer quotes from car dealerships and what they think of the use cases we're able to provide with our identity graph. The first one is Kevin Patterson. He's the vice president at a car dealership. Here's what he has to say. Connect Automotive Intelligence has really helped us identify in-market shoppers within our CRM database, oftentimes prior to the customer raising their hand. This is exactly what we talked about at the beginning of this talk. They're able to reach out to customers before the consumer reaches out to the dealership, which gives you a great opportunity to make sure that you reach them before a competitor does, or before they reach out to a competitor. Second, I want to share the experience of Andy Gulicker, who's he's a general manager at a car dealership. He has this to say. Because we're using this technology, we're able to improve the interactions that we have with customers and really tailor conversations based on their interests. And again, that's what I was talking about with car dealerships and making sure the salespeople are really selling you what you want to buy and not creating a bad experience. So overall, I think what we're saying is we're seeing that our customers find this very valuable, the types of experiences we're able to create. And we're also seeing internally from a data science perspective that we're able to provide more accurate, more reliable insights with our identity graph. And it's very valuable. So that's really all I have to share with you today. I do want to mention that we are hiring if you find what we're working on at Cox Automotive interesting. And beyond that, thank you for listening into this talk. And I do want to share that we have the session survey, so please fill that out. That's how we help you get very interesting talks for yourself.